The use of those materials that we just looked at will play into the technology that is used in Japanese architecture. Now, most Japanese architecture is based on a very simple post and lintel design. I'm going to pull up my pen here. So here we have a post and we have the lintel over the top. This is a very simple form, something we've seen from Neolithic and Paleolithic times in the form of Stonehenge, something that's a very old form. And what they're doing is they're generally spacing these columns about 6 to 10 feet apart. This is a very common spacing. It's what we see in a lot of medieval European construction, and we're seeing it here in Japan. That's because that's where you see the structural strengths of wood. If you go much further than that, you have to start getting into arches and modified forms, which the Japanese are not typically getting into with a lot of their architecture. There's just no reason for it. They don't have a need for giant living spaces. It's a different culture. Their construction for even homes is going to be mortise and tenon. Now, we keep coming across mortise and tenon, but it's really, really common. And all they're doing, there are various forms of mortise and tenon, as we can see here in the rafters of this massive temple, or here in a piece of new construction. But here, basically, the wood goes, one rafter goes through the column, and then it's pegged in place. Why are they using mortise and tenon? Why not just nail things together? Well, the thing is, earthquakes are a problem in Japan. So if I have mortise and tenon construction, it allows all of those elements, just looking at this joint, to move independently. At worst, this peg may back out a little bit during an earthquake, but this rafter can move just a little bit inside the column. The column can move a little bit. And during an earthquake, the last thing I want is for the entire building to move as one, which is what we would expect in, for example, stone and mortar construction, where the entire thing is basically glued together. And so all of those forces get stronger and stronger the bigger the thing they're acting on is. So when we have mortise and tenon, each individual element within the building vibrates and shakes during an earthquake, but they shake independently, which means you don't have the harmonization that tends to destroy buildings. Consequently, we see mortise and tenon construction used throughout. You will rarely, if ever, see iron used in construction. It happens on occasion. For example, here we've got a couple of iron hangers, but it is exceptionally rare in Japanese architecture. In primarily agricultural areas, we will see Waddling Cob construction. Now, many of the houses will have frames with paper or fabric laid into them to create walls. They will use wood as well. But in certain areas, we see Waddling Cob, which is basically the same as wattle and daub, which we saw in Europe. The difference here is they're using sticks that are basically tied together, and then you see the plaster pushed through them. Here, part of the wall obviously has been removed so that it is exposed. When the plaster is pushed through whatever the underlying material is, you see it kind of pours down, and that's called keying. Once it hardens, it stops the plaster on the surface from coming off. And it's really cheap, easy construction. To create that plaster, all I need is lime, which they have plenty of in Japan, and sand. That's it. That's your basic plaster. So these are materials that are commonly available. It's the sort of thing your average farmer could put together. And it doesn't have to be perfect plaster. Sometimes we'll see something more similar to adobe, where it's mud and straw, but it's basically the same idea. In terms of roofs, we tend to see very Chinese forms here. So they will have a very wide roof. This is to protect all of the wooden structure underneath. You tend to have curved roofs, and most of that is aesthetic. It just looks better. It looks more impressive. And sometimes we have very complex forms. So here we actually have this central roof with a dip in between, in the middle. And that's going to allow, for example, snow to come off of the roof. Obviously, snow buildup is a huge issue, especially in northern Japan, where you can get snowfalls of 2 and 3 feet, the sort of thing that could destroy a roof. Now, part of that construction is going to be the use of Tokyo brackets. And what this is, it's a system of supporting blocks and brackets supporting the eaves of the building. These are necessary because of those really wide roof lines. To build the roof line so far out from the building, of course, I need to build something up to support it. Now, I could just put a diagonal piece in here, potentially, but then it has a point of failure here. Whereas with the bracket system, as they build this up, they're cantilevering the design. Now, cantilever simply means that I've got one end unsupported, and then it's supported at one end. This is how many bridges today are constructed, from each end, and then once it's connected, it's no longer a cantilever. So they're doing that, but by building it up slowly, what they're doing is building a more solid form, something more similar to a corbel vault that you would see in the West. The corbel vault idea, which is used before arches and other forms, is simply to build up stones so that one is sitting just inside the other, to build up an archway or to build a dome, as you might see at Newgrange in Ireland. So it's the same basic idea. And here we see it a cross section, so you can see those various steps out to basically support that really wide roof line. We also see the structures are raised up, very similar to China once again, because the wood, if it's in contact with the ground, will simply start soaking up moisture from the ground. This will lead to rot. So by putting it on a raised structure, this could be stone, this could be stilts in some cases, they avoid a lot of those issues because you're putting space between the structure and the ground. And Japanese construction from the outside looks very, very simple. A temple like this looks like basically post and lintel, and it's very straightforward. But in reality, there's a lot of curved members under there that are holding up that roof line. We have our brackets, our Tokyo here. Everything is far more complex than you would at first think. And keep in mind, this is all mortise and tenon, so all of it has to be joined just perfectly. So we see very skilled Japanese craftsmen who are capable of putting together a structure without the use of iron implements, and a structure that can live or last for hundreds of years in many cases, as long as it has appropriate upkeep. So it's remarkable architecture. It looks very simple from the outside, but it's actually very complex as we start digging into it.